Students, in the given question, we have been provided that while studying the decomposition of gaseous N2O5, it is observed that a plot of logarithmic of its partial pressure versus time is linear. What kinetic parameters can be obtained from this observation? So in this given question, we have been provided that the plot of logarithmic of partial pressure of N2O5. Okay, so we can refer this as P upon P naught is linear with respect to time. Okay, so linear means this will be the slope of the curve. Now we know for a first order reaction, log P upon P naught is equals to minus K upon 2.303 T. Okay, so on comparing, we can see that the decomposition of N2O5 follows first order. Okay, as we can see, both have similar relation between the partial pressure logarithmic versus time. Okay, and when we draw this curve of log P upon P naught versus time, okay, log P upon P naught versus time, the slope will be minus K upon 2.303. So from this curve, we can easily determine the rate constant for the decomposition of N2O5 for the given reaction. Okay, so two things we can find with this curve. First is the rate constant, and second, we can prove that the reaction follows first order. So these are the answer of the parameters we obtain from the given data that states that the logarithmic of partial pressure versus time is linear. Okay, so these are our answer for the given question.
Hello everyone, let us solve this question. The question says a first order reaction is 20% complete in 10 minutes. Calculate the specific rate constant of the reaction and also the time taken for this reaction to reach 75% of the completion. So we have been given a first order reaction. We have to tell that when reaction is 20% complete, what will be the rate constant and what will be the time taken for the reaction to reach 75% of the completion of reaction. So according to the first order reaction, we know that K is what? K is equals to 2.303 upon T log A0 upon A0 minus X, where A0 is what? A0 is the initial concentration of reactant and X is the amount of initial concentration of reactant reacted to or converted to get product. So now we have 20% reaction complete in 10 minutes. So the time is 10 minutes and let us assume that the initial concentration of reactant is 100. So if we assume 100%, if we assume that the initial concentration of reactant is 100, so if 20% reaction is complete, that means 20% of A0 is converted to product. So 20% of A0 is what? 20% of A0, that is 100, is 20. So the amount of initial reactant converted to product is 20. So the value of X is 20. Initial was 100 and the amount of A0, that is initial concentration of reactant, converted to product is 20. So what will be the K? K will be equals to 2.303 upon 10 into log 100 upon 80. This will be 2.2 into 10 raised to minus 2 minute inverse, because this is a first order reaction. Now the second part says that we have to calculate the time for which the reaction is 75% complete. That means X will be what? X will be 75% of initial concentration of reactant. That means 75% of 100, because we assumed A0 value to be 100. So this will be the amount of X, that is amount of initial concentration of A converted to product will be 75. And also we have the value of K, so we can easily calculate the T. So again using the same equation, K is equals to 2.303 upon T log A0, that is 100, upon A0 minus X, that is 75% reaction is complete. So the amount in gram will be 75 gram, assuming that total mass of the initial concentration of A is 100, right? So now we have to calculate T. K is already we have calculated. So from this T will be 2.2 into 10 raised to minus 2 equals to 2.303 upon T log 4. So from this T will be 2.303 into log 4 divided by 2.2 into 10 raised to minus 2, and it will be 63 minutes. So the final answer is time 63 minutes to convert for the 75% completion of the reaction, and the rate constant for this reaction is 2.2 into 10 raised to minus 2. Thank you.